Okay, so I am Peter Smallage. I'm the New York State Extension Forester. It's Wednesday, April 20th, 2016. It's my pleasure to welcome you to this month's edition of the ForestConnect webinar series, brought to you through Cornell University Cooperative Extension, and I am delighted to have as our guest speaker today Mark Whitmore. Mark is a friend and colleague here in the Department of Natural Resources at Cornell. He's my go-to bug guy. I'm out in the woods, I take pictures, and I send him pictures, and I say, Mark, what is it? And he always gives me an answer back. And as far as I know, he is always right. So with that, Mark has agreed to talk with us about bugs in sugar maple forest. Mark does a lot of work with really bad bugs, and you've all have probably seen some of his presentations on specific bad bugs, and this is a more general presentation about kind of forest entomology with a focus on sugar maple forests. So, Mark, I'm going to mute my microphone, and you have the baton, and you can go to it. Thank you very much. I'll hover here in the background. Lurk. I'll lurk. I'll lurk. I'm not lurking because you can.
Okay, Pete. Well, thank you very much. You really. I'm sort of embarrassed. Are you sure I got all those bugs right that I identified? But anyway, hello to everybody. I'm really impressed at the geographic distribution of this crowd. It's quite an honor to be speaking with you right now. And I just want to say up front, if anybody has information on the bugs I'm going to talk about, infestations or whatever, I'd really like to hear it because my experience is stuck pretty much here in New York State. And if there are bugs that create problems where you are that I'm not mentioning, or if there are extraordinary circumstances surrounding some of the bugs I'm talking about, I'd love to hear it. Of course, that leaves out Worcester, Massachusetts, because that's the big bad bug, which I will address. So basically, I'd like to talk just generally about bugs to begin with. Forest entomology is bugs in trees. And my first axiom of forest entomology is if there's something to eat, there'll be a bug to eat it. And you all know that trees are complex organisms. They have lots of different parts, and consequently, there are lots of specialists on those different parts of the tree. My next axiom is that native insects are actually beneficial. A lot of the bugs I'm going to talk about today are native, and it's like the lion taking out the weak antelopes in the crowd. And this picture is in Colorado, actually, and I grew up out west studying bark beetles, and it was a rather bucolic profession before we got these invasive species coming in, because I'd work with just the ones that would occasionally take out tree here, tree there, tree here, and try and minimize the potential for the native insects to go outbreak. As you know, the paradigm has shifted with the introduction of the Asian longhorned beetle and other insects, emerald ash borer and hemlock oleodelgid. So just a brief discussion on what keeps these natural populations controlled. And it's a combination of these three things, basically. Host tree resistance, we don't really understand it for all the forest insects we work with. In fact, we don't really understand it for every forest insect as far as I can tell. We have indicators, but really nailing it down and being able to work with it is something that is elusive because it's very complex. And it changes with time. Young trees can be resistant to something, and as they get older, they'll become susceptible, or as how would you say, as things change, like the soil gets inundated or things like that. Abiotic factors, temperature and humidity are all a part of it. Humidity will actually help the growth of fungal pathogens, and temperature can literally kill bugs given different times of the year. And then there's biological control, predators, parasitoids, and pathogens. So these are all wrapped up into one. So basically, it's like everything contributes a little bit to the control that keeps native populations of native insects in relatively a static mode, and only occasionally do they become outbreak. And when they go outbreak, that's when we pay attention. As I mentioned, host tree resistance is a combination of genetics responding to the environmental conditions. There's genetic resistance. It's acquired through interaction with the pest over many generations, and they basically co-evolve. And it's incorporated into the genome, where the environment acts on the genome and can alter resistance over time. So one of the things that I think about when I'm traveling around looking at woods, what are the stressors that trees see? And I look at sugar maple, and there are a lot of things out there that sort of come together. And the whole time I'm thinking, well, what is causing outbreaks, and how do these stressors operate on the tree that influences the interaction with the pest? Abiotic factors are important. Wind, cold weather is very important. Sometimes the freak spring frosts will hit the trees and take out the leaves, causing a second flush. Drought and flooding, basically physiological drought when you flood the roots, and then physical damage. You run into a tree with a skidder or with your car, and it's going to hurt it, or the bulldozer hits the roots of the tree. Biotic factors are also present. Microbes and fungi, you get fungal pathogens in the roots. You get stem infections causing rot of the wood. And then you got insects and animals chewing on the trees as well. We love our deer around here in the freezer. So basically, foliage is a very important tissue for the tree. We got buds, flowers, leaves, and seeds, and that's without leaves, the tree obviously won't grow. And whenever the leaves are consumed, that impacts the tree, but it depends on when the tree is defoliated. There's insects that specialize early in the year. The damage from those early defoliators is much more intense than the damage from those that feed later on in the season. But I'll submit to you, I think that damage to the foliage always influences the sugar production or the quality of the sap. Chime in here if you think I'm wrong, Pete. But so the different insects on sugar maple are forest tent caterpillar, pear thrips, gypsy moth, saddle prominent, spring cankerworm, maple leaf cutter, and the maple trumpet skeletonizer. I'm not going to talk about all of these, but those that I feel are the most important, at least in the forests around here in New York State. Then we get to the wood. There's different components to the wood, and indeed there are specialists in those different parts of the wood. Everybody, of course, knows their wood anatomy. So with the bark, the tissues are the cork, the phloem, and the cambium, and there's insects of the maple borer, maple agrilis, large oak bark beetle, and the wood borers are the Asian longhorn beetle, which we'll talk about, red-headed ash borer, broad-necked root borer, and the maple borer, which I didn't get on that list. I'll be darned. But anyway, suffice it to say, there's the wood tissue. Oh, there's the wood specialists. We have the Asian longhorn beetle, the red-headed ash borer, broad-necked root borer, horntail wasp, leopard moth, and ambrosia beetles. Did I miss a slide there? No, I didn't. Here we go. What's going on here? There we go. So let's sort of launch into the bugs. And no discussion of maple insects is complete without talking about the threat of the Asian longhorn beetle. This threat has been realized in a number of locations. Hopefully, it will be eradicated. I think it's very much an important activity the USDA APHIS is engaging in right now, and I hope that they are successful, because this truly is one of the scariest bugs facing us. One of the problems with the Asian longhorn beetle is its host range. It likes sugar maple and red maple, of course. Norway maple, well, I could live without that one probably. But box elder, birches, American elm, poplars, willows, horse chestnut, and ash. And I think recent work has sort of shows that red maple is perhaps a preferred host over sugar maple, but I'm not going to wait around and argue about that. This is a really scary insect. It came over from Asia, from China. The story is interesting. I guess it was a sort of not very common insect in China until they started planting out the poplar for windbreaks during the I forget when they were doing that, in the 50s or 60s, and it happened to be a very palatable species of poplar to the Asian longhorn beetle, and the populations of ALB increased, and of course, as we all know, probably got over here in wood packing material. Now, it's really important, and you probably have heard this before, but I can't help but say we really need to pay attention to the signs and symptoms of this insect, because early detection is absolutely crucial to our possibility to eradicate it. And one of the things is the adult beetle itself. As you see here, it's a shiny beetle with the white spots on it. There's a very similar beetle, and I probably should have had that picture on here. It's the pine sawyer. It's smaller in stature. It comes out earlier in the year, and the white spots aren't as distinct. It's much more like a pattern of dust on the elytra in particular, and it's not that bright, shiny black. It's a dull color. But the important thing about the adult is that it actually bores straight out through the wood as it emerges. And if you get a pencil and you put it a couple inches into a hole, like these holes, you'll know that that is likely the Asian longhorn beetle, and you should be on the phone calling the local experts immediately. So it does look like basically somebody's been taking pot shots at these trees with a rifle. Here is another very important character, the egg niches. It takes a little bit of time for the female to lay her eggs, but she eats down in there very rapidly, actually. Mouth parts are very strong, and she inserts the egg in that niche. And these niches actually are, you can see here's a fresh one right here, and here's an older one. So actually you can go into a stand and you can cut down trees, and you can sort of look at the oviposition history in that stand by looking at the age of the egg niches in the trees. This is another interesting character. I don't know of any other insect that eats only the midrib of the leaf. It's something that's sort of noticeable if you're paying attention to leaves, and if you see this, you should begin looking for other characters as well. Frass is a very good character. It'll collect. You see here, and on the tree itself, this is where a piece of wood, the excelsior-like boring fragments from the larvae, and there's a very large larvae here. You can see this is the head and the tail here. I often think that, in a nice sugar maple tree, these would probably cook up really well with some garlic and olive oil, but it's not going to affect the populations. Sorry about that. Entomologists, we have weird ways of relating to bugs, but they really are, it's like a lot of the bark beetles and such are really delicious from pine and spruce. I'm getting off track, sorry. So the frass, here it is collecting at the bottom of the tree. And here's some of the white boring dust here. So that'll collect. It'll blow around. It'll be on swimming pools and such. It's important to pay attention to that. Actually, it's interesting. One of the ways it's been detected was the New York State DEC put out a swimming pool how'd you say, a flyer to swimming pool owners down in Long Island where we have one of the infestations, and they said if anybody finds this beetle in their swimming pool filter trap, give us a call. And lo and behold, they got a new infestation. This is what I look at when I look at loads of firewood moving down the road. You get this is the boring of the beetle larvae in the tree, and it's very easy to see even from a distance. It's very characteristic in maples. So this is the scary thing. It's potentially the damage is just incredible, and just in the United States, $600 billion in damage, considering all the different aspects, tourism, maple syrup, and everything. And this is a pretty detailed economic study that went into generating that number. And it's a good one, though, because we need numbers like that to realize that our efforts put into eradication are important and very well justified. Eradication was successful in Illinois and New Jersey, and in Toronto it was successful, but lo and behold, they got a whole new infestation in Toronto, and so they're still working on it. Long Island, they are still working on it hard there. So we have success stories, and it's important to pay attention to that because we have a really big problem in Worcester, Massachusetts, and in Bethel, Ohio. In Worcester, it's been there since a homeowner detected it in 2008. The quarantine has expanded to 110 square miles, and it's stayed static at that point for a while. So I'm hopeful that they've got it basically contained, and they're just busy mopping up here and there. Many trees are taken out and chipped, and a lot of effort's gone into inspection and such. In Bethel, Ohio, first detected in 2011, and again, they're still cutting down many trees. These numbers, I'm afraid, are a little bit old. I've neglected to update them since I got the most recent information. But this is impressive. 1.7 million trees surveyed. That's a heck of a lot of trees, and I'm very thankful of the effort that's going into eradicating this insect. The forest ant caterpillar is something that sorry, I didn't put in the scientific names. I didn't feel like it was necessary. This is an insect that we have problems with in New York State, and the last big infestation was in the mid-2000s, and it was a very interesting phenomenon. Now, this is a native insect. Populations go up and down, and the interesting thing that I found when we were undergoing the infestation, the outbreak in the mid-2000s, was that the outbreak seemed to start on the drier soils. Once again, I'm sort of going to harp on stressors because I feel the stress, it does something to the tree. It changes it. It's like exactly what it does, I don't know. It alters the chemistry, maybe. I'm thinking on the drier slopes, it might inhibit its capacity to produce secondary chemicals that it normally have. Does it influence bud break? Bud break with these early defoliators like forest ant caterpillar is that timing could be absolutely crucial for the successful establishment and growth of the populations. So what happened, it was quite interesting. On the drier soils, the populations would come up, and they persisted for a couple of years, and it actually got quite widespread in the Catskills and in the southern tier region here around Ithaca. And then the populations in most of the places collapsed due to probably fungi, viruses, and what we're calling the friendly fly, a little parasitic fly. The interesting thing is that it actually persisted in some locations, and I still scratch my head about that. I don't know why it persisted, but actually, and I've spoken with a number of people that have said, "Oh yeah, that killed a number of trees," and so. In fact, I have one friend that I'm the beneficiary of the fact that he lost almost 5 acres of sugar maple. But that was on a hilltop. I think the soils were drier, and maybe there were other stressors involved as well. I know that most of the trees that were killed, they exhibited signs of armillaria, the shoestring root rot. Now, did that become aggressive? It's like a big question with armillaria is it's always out there. It's ubiquitous across the environment, and what exactly goes on in the interaction? Is it normally benign, and does it indeed help the trees normally, but then somehow something pushes the tree over the edge, and what is normally a plus interaction with armillaria, maybe the armillaria gets aggressive, and then can help kill the tree. I don't know this. I think it's always good to pay attention to armillaria, and I don't have a picture here. I should probably slap one in for the next talk. But armillaria, when you look at a tree that's died, I always like to hack into the base of the tree and peel off the bark and look in the cambial area and between the wood and the bark. And when it's just fresh, there'll be a white felt mat of armillaria on the tree. And over time, after the tree dies, you can actually do your forensic forest entomology or forest pathology. You go into a stand and you pull the bark off of a tree that's been dead a while, and that white mat actually changes into dark shoestrings, or that's what we call it, shoestring root rot. Shoestrings, it's a resistant form of the insect, of the fungus, and we call it a rhizomorph. So it's always good to sort of like think about all these different stressors that are involved, and that I think that the forest tank caterpillar has taught me a lot about sugar maple and the dry sites. And indeed, on some of the dry sites, same dry sites that I saw the forest tank caterpillar get started on, indeed there was a drought a few years previous to the forest tank caterpillar outbreak that actually killed some very large established trees as well. The forest tank caterpillar can be distinguished from its congener, the eastern tent caterpillar, because it does not make a web. The eastern tent caterpillar loves to get into the black cherries, and it makes a beautiful web. So that's how you tell them apart. So another one of the defoliators, a native defoliator we have, it's fall cankerworm. This is a native looper or inchworm. It's in the family Geometridae. Lots of geometrids out there. The fall cankerworm feeds on a lot of different tree species. It's not a sugar maple specialist per se, but it does impact sugar maples. It can defoliate large areas, but not very common. I have not seen really severe defoliation by fall cankerworm, in the past 30 years here in upstate New York. If anybody else has seen it, I'd like to hear about that. Can cause severe defoliation. Once again, this is an early defoliator. So when it actually causes severe defoliation, it might cause the tree to refoliate. And once again, it's very, very dependent on bud break. It's a timing issue. So what happens is basically the caterpillar eats the leaves, it drops down into the soil, develops into an adult. The adults emerge in fall. And that's why they call it fall cankerworm. They mate, and the flightless female lays their eggs in the fall on the tree, and the larvae then the egg is the overwintering generation, which then hatches with bud break and begins feeding on those newly emerging leaves. So I think it's the timing, once again, as with the forest tent caterpillar, is crucial. And of course, bacterial and viral diseases help regulate populations as well as predators and parasitoids. Now, it's interesting, this fall cankerworm and the Bruce spanworm as well, they both were present, but they came and at the same time as we had the outbreak of the forest ant caterpillar, but they were sort of at the tail end of the infestation, and they didn't persist for very long. So once again, my question in my mind is, did we somehow get a perfect storm that allowed them to get that phenology, that bud break at the specific moment that allowed them to be much more successful? I don't know, but that's one of the things that's going to be changing with time, and I think that we have to consider with climate change, what is it about the environment that's going to change that we need to pay attention to, and we're going to have to roll with the punches. We're going to be changing the way we think about insects and the knowledge that we have about them. We're going to have to consider how that might change, and this is one of those instances. Blue Spanworm, it's also a native looper or inchworm. Once again, it does feed on many tree species, but it seems to prefer sugar maple and beech in New York and in the Northeast. Interestingly, it does cause widespread defoliation. I forgot about the going back to the there we go, fall cankerworm. I forgot to put in there. There was some widespread defoliation in Pennsylvania, I think in the 50s and 60s and maybe the 70s as well. So, there is a history of defoliation. But and as the same with the Bruce Spanworm, history of defoliation. It was one little tidbit was that there was actually, in 1957, 10,000 square miles in Quebec that they attributed of defoliation to Bruce Spanworm. So, here again, we have a defoliator. It has the potential for widespread defoliation, but I haven't seen it do much in the past couple decades. And I'm sort of wondering, are these things disappearing, or is it dumb luck on our part? Is there some aspect of the phenology which also is very important with this insect? It's very similar to the fall cankerworm in that the adults emerge in fall. They may lay their eggs, and the eggs overwinter, and then the larvae hatch with bud break. And so it isn't the bud break itself that triggers the hatching of the egg, it's other environmental things. So if something retards the bud break of the tree, we might lose that cohort of the population because there's nothing to feed on. So there's a lot of questions surrounding these insects and what controls their population growth that we just don't have a handle on right now. But we need to pay attention to them because I wonder, what is going to happen over time with these various insects that are native. But then, they may become aggressive given different circumstances. We don't know. Now, parathrips is an interesting one. This is a bug I remember in the 80s. Everybody was all nervous about it. It was first imported from Europe, first detected actually in California, I think 1907 or something like that. And it spread quickly across North America, and it was noted on fruit trees in particular. But it was first reported causing widespread maple defoliation in Pennsylvania in 1988. I think we had some warm-up calls with that in the 70s, the late 70s. It was first found to be causing defoliation. There was a term for it, maple malady, I think is what they called it, before they actually determined that it was feeding by this imported insect. Now, this is a teeny tiny little thing, a couple millimeters in size, and the adult comes up out of the soil. It spends most of its time in the soil, about 9 months. So in spring, when the buds are breaking, the adult will come up and it will begin feeding in the buds, and it will lay its eggs in the developing tissues, and the larvae will then feed on the leaf tissues and cause, you can see the deformation there in the picture to the left. You know, it's sort of, it isn't complete defoliation, it's damage. I think sometimes the damage can be far worse. These leaves don't look very bad. But one of the problems with pear thrips is that it also introduces anthracnose. And so, you know, it's a very complex interaction that affects the tree. The trees lose their leaves and they'll be forced to refoliate. And so this was actually very widespread. I remember the big infestation in 1988 had everybody really worried. But since that time, basically, I've spoken with my colleagues actually just recently asking, you know, has anybody seen pear thrips? And nobody's seen it really do anything since that time. And it's a very curious thing. You know, here we have an imported insect, you know, an invasive, non-native insect. Everybody, you know, it's like after getting beat up on emerald ash borer and hemlock woolly adelgid, I'm just sort of wondering, well, what's going on with this one? It's not really around anymore. Has it gone away? No. But you know, what's going on? Is there something that's in the soil that all of a sudden has come forward and controls the population in the soil? Is there something about the timing that they're just not getting right? And you know, that's something that's very real with a non-native insect. They just haven't evolved the mechanisms to get their timing exactly correct. So there's a lot of questions about pear thrips. We're not really, you know, really worried about it anymore. But if there's just something nagging me about this, and this is one of these bugs that, you know, we really need to know what's going on out there. And so, you know, that's why it's so important when you do get defoliation in your forest that you be sure, you know, you see a widespread defoliation, you know, 10, 20, 30 acres or so, you really want to get somebody in there to take a look so we can sort of like think about what's going on and the causative agents and develop our knowledge base more thoroughly. The maple leaf cutter is something that's always out there. It's, you know, I've heard about it regularly. It seems to just, every once in a while, there'll be, you know, 5, 10 acres or you know, rather low level presence of the maple leaf cutter throughout the state here. It's widely distributed. It prefers sugar and red maples. You also find it on beech. Again, it begins feeding early in the season. You see the adults there on the left. It's a very beautiful insect. That's actually, it has a metallic bluish hint to it, very dark in color. And actually, you can see it on the leaves. They lay their eggs on the top of the leaf. And then you can see the adults laying the eggs. You see their image from the underside. It's pretty cool looking if you're an entomologist. So the eggs are laid. Actually the egg hatches and it goes into the leaf. Actually, but it's a leaf miner. It feeds between the epidermis, the upper and lower epidermis, mining out the chlorophyll. And after a little bit of time, it then comes up out of that feeding spot and makes a little how would you say, it cuts out a piece of the leaf and pastes it over it, so it makes a little feeding shelter. And here you see up on the left-hand side, there's all these places where it's been feeding on the leaf. So it's a very characteristic, very easy to see and identify this insect. In September, they descend the tree with the cases attached, and they pupate in the soil. So this is an insect that's not really as dependent on the phenology or of bud break. But it's also important because, you know, once again, it is a defoliator, and maple growers have mentioned the fact that they feel the quality of their sap is actually how'd you say, degraded by the defoliation surrounding this. And one thought just came to mind. I think it's really important if you're a maple producer and you get defoliation in your stand. I think it's really important to give that stand a rest. You know, don't take either don't tap the trees or don't take as much from the trees the following season, because basically that works like a defoliator. The defoliators, they basically sap how to say, sap the carbohydrates of the tree, forcing it to put out a new flush of leaves. And so, it's like you got to let them recover after a defoliation event, and not keep taking away from them, because you gradually, you're stressing the trees even more by doing that, and who knows what will happen after that. One of the more interesting and beautiful insects that feeds on sugar maples is the leopard moth. This isn't a really common insect. I just think it's a cool insect. Basically, it's first detected in New Jersey in 1887, and it has spread all throughout New York State. I see it pretty much everywhere. And it's the eggs are laid on the bark. The first instar larvae then bores into and begins feeding on the wood, and it creates a rather large feeding wound. You'll see the big tunnels when you're splitting up your maple firewood. It's just a really interesting insect, nothing to be concerned about. Populations, I've never seen populations get outbreak and cause a lot of damage. But once again, it's like the times are changing, and this is something that we maybe need to pay attention to. And it's so easily recognizable that we really should not ignore it. So thinking about wood insects, the horntail wasps, I think, are one of the coolest that we have. And this is something that, it's a native insect, and you might have heard about the Syrinx noctilio. I'm trying to think of the common name, but it feeds on pine trees. This is a very similar insect to the Syrinx. Syrinx is a huge problem in the southern hemisphere, where the non-native pines have been planted and grow rapidly. Here, it's a native insect. I think it has natural control mechanisms in place so that the populations don't go crazy. But on the other hand, I remember when we had beech bark disease moving through this area, the horntail wasps were absolutely everywhere, and it was really cool because they're a beautiful insect. You can see there. They actually scare the living daylights out of people because they look like a huge wasp that's going to sting you. But of course, the only thing they sting are the trees. They lay their eggs by actually pushing their ovipositor into the wood, and usually the wood is already beginning to degrade. They introduce a fungus that they then feed on in the wood as a larvae, and the long meandering galleries underneath the wood are tightly packed with frass. So it's easy to identify when you cut down a tree and you're going through your firewood. You'll find pockets of these insects in there, and it has a 2-year life cycle. So it's in the tree for a while, boring around. It'll weaken trees, and the biggest damage, I think, is it might cause branches to fall off or trees to split. But really, this is an indicator, much like the lions taking out the weak antelopes, that you have a tree that probably needs to be taken out anyway. So it's useful in that respect. And I got to say at this time that if ever you find these things, it actually has a parasitoid, a parasitic wasp that is absolutely phenomenal to watch. I actually had a bunch of sugar maple firewood that I was working on, and it was in spring, and I remember the horntail wasps were emerging, but so were the parasitoids of the wasp, and they have an ovipositor that quite literally is about 4 inches long. And it's one of the most amazing entomology stories, because what it does is it actually oviposits through a few inches of wood and into these larvae. And I've always been fascinated by the behavior, because it takes a long time for these parasitoids to get into the horntail wasps. They spend, like I've seen them drilling holes into the wood, trying to find these hosts for like a half hour. And at the same time, they're vulnerable to birds. And so I remember when the beech bark disease was here, you'd see these wasps just covering the outside of a beech tree, and invariably there would be the last abdominal segment attached to an ovipositor that's been inserted into the tree. And I think the birds learned that these were just basically sitting prey, and they would wait for them and then snap them up, and they would leave their bit of their abdomen and the ovipositor in the tree itself. So it's a really fun entomology thing. Horntail wasps are harmless, but they're interesting and something that once again, pay attention to it. At what point does a tree become susceptible to the horntail wasp? Maybe the stressors can work on them, and somehow the horntail wasp will sense that tree is at the right point to attack. I don't think it'll ever be a primary tree, but it's interesting nonetheless. The sugar-makeable borer, on the other hand, is something that can be a problem, and you can see here that when it gets into the tree, it can cause, by boring into the wood, it can cause a lot of damage. This is the outward signs of its presence in the tree, in the bark. I don't know if I see this actually quite frequently. I know that in some instances it's been found to be very common in some areas. Excuse me. I'm sort of doubtful that it's like really aggressive insect. I think that very much like the lions and such, it is a secondary insect. It'll basically tell you which trees you need to thin out of a stand. So the adult emerges and lays eggs on the bark. In the summer, the larvae bores into the bark, feeds in the phloem tissue for a while, and then dips down into the sapwood to overwinter. And you'll get a wet discoloration on the outer bark, and over years you'll see this wound begins to heal up over it. So it's really absolutely a gorgeous insect. I don't know if you've probably seen it. You think maybe it's a wasp or something, and that's probably intentional for protection. But it really is one of the most beautiful longhorned beetles that I see in the woods. So what else do we have here? And then we have the European shot-hole borer. This is a very interesting group of insects called ambrosia beetles. And so this is first found in Massachusetts in the early 1800s. So it's been here a long time. And it does get into the wood. It causes damage to any kind of quality timber. So ambrosia beetles have an interesting life history. The adults, the female will excavate a hole in the wood, and here you can see this powdery stuff is actually caused by the female excavating the hole. And so she excavates these tunnels, and at the time that she's excavating them, she's actually inoculating the tunnel with a dark fungus. And the fungus is actually kept in the female in a modification of the pronotum called the mycangium. And so the fungus comes out and inhabits the wood and grows, and the eggs are then laid in these tunnels, and they hatch, and they don't feed on the wood at all. They feed on the fungus that's in the tunnel itself, or the fungal hyphae. So it's an interesting interaction. The interesting thing for me is that it's very, very sensitive to the moisture of the wood itself. I've seen some trees that, basically, I remember it's a classic situation where there was somebody cutting firewood, and they got the top of the tree caught up in another tree, and so they lopped off the bottom part of the tree, the bottom 10, 15 feet, and then somehow they left the whole thing up there. And so the ambrosia beetles only infested the part that was on the ground. that didn't infest the upper part of the tree. And so I was scratching my head, and of course that makes sense because the lower part of the tree that had the top lopped off of it still maintains a good sense of moisture, a good amount of moisture in it that is important for the growth of the fungi in the tunnel, whereas the upper part that had the leaves on it dries out a lot more rapidly, and so that was not acceptable to the beetles, and so they didn't get into the top part of it. So this is another reason you don't log sugar maple in the springtime or early summer, because you can get the shot hole borers in the tree, and they will degrade the quality of the wood rapidly. And indeed the dark stain from the tunnels will actually grow through the wood to a certain extent as well. That's right. She's attracted to the ethanol emitted by stressed trees, and that's, it's like, again, the stressors are in play, and so it's just another one of those bugs that can sense when you got a stressed tree. And so I've been thinking an awful lot about what's going to happen, how with climate change, and these models, they've been up there a while, and they're pretty solid. The science behind them, the physics have been worked out, and this is sort of interesting when you look at, here we have in New York State an amazing density of sugar maple. It's one of the most common trees in the state. And then you look just almost 80 years down the road, and it's really changed. And indeed, if you look down here in Tennessee, it's basically been extirpated with this model. This is on the right-hand side, this is the data. Basically, this is based on the FIA data from the U.S. Forest Service by Prasad and Iverson and Matthews and Peters. And so this is the model on the left is the current distribution of sugar maple based on their model, and it mimics very carefully the actual data. Whereas here you see that sugar maple has been extirpated down here in Tennessee, throughout most of Kentucky, and even out here in Indiana and Ohio, whereas now there's actually quite a bit. And so and even in even in New York State, you see that it decreases in density over time, maintaining itself only in maybe the upper reaches of the Adirondacks and the Catskills. So what's going to, I just keep questioning, what's going to happen? What does that mean? And when you look at, I think, insects, forest insects, native insects, they are very, very sensitive indicators that a tree is stressed. They'll take it out. That's their job. That's what they do. So I'm looking at the gradual change in habitat as a way that it's that interaction, that delicate balance with the insect pests that I think is going to be one of the things that we're going to start seeing as a part of the climate change. When it's going to happen, why it's happening, I don't know. Will it be just because of, just that shift, that little bit of shift in phenology? I don't know, but just thinking about it, here's a slide with what I call the current habitat, and you can put anything on these axes here. I would consider it an n-dimensional hypervolume. Basically, this is the area where the tree is comfortable right now. Longitude and latitude are just a couple of the things that you could think about. Well, what happens with time, with climate change? Here you get a habitat shift where it's going to move, and you get the area of colonization here. That's the yellow part. There's just a few trees that are left, or a certain portion of the population, or the herd, as some of my colleagues refer to trees. I actually like referring to populations of trees as herds. They don't really move very rapidly, but they do move across the landscape. And this portion is going to be stressed. So what happens in this stressed area? Are we going to have insects that aren't normally problems all of a sudden become a problem? Are we going to turn insects that are normally secondary insects into primary tree killers? Are they going to be creating more problems? I don't know. But I can't help but think that it's going to be a very interesting time period over the next few decades, watching how things change and watching the different pests and how they respond to that change themselves. Yes, we're in exciting times in forest entomology. And so I can't end my talk without this slide. I almost got beat down by some of my friends when I tried to end it without this, and they complained loudly. So, as with all trees, we got to be careful about moving firewood because who knows what's going to be moving with it. And with that, I'll take some questions.
Mark, this was great. Thank you. So I'll start with one. I remember, it's been a few years ago, I was up in St. Lawrence County in northern New York, and I had my first encounter with Leucanum scale on sugar maple. How are you familiar? I'm assuming you're familiar with that at some level. Do you know, is that common? Is it? It was. I thought it was neat because that's like neat in an entomological sort of way. They would drip sweetened whatever on the ferns, and then the ferns would get a mold, kind of a black mold growing on it, and so that was, that was the cue that there was something going on. Was there's like this sheen and black, goo on the ferns, and then we figured out it was from droplets from the Leucanum scales. So.
Yeah.
Any.
I haven't.
Do you see that around much, or?
I don't. I don't see it around a lot. But when you do see it, it makes an impression, doesn't it?
Oh, it is. Yeah.
And then you get the wasps that are circling around, so no, I don't. Does anybody that's in the that's online here, have you all seen the Leucanum scale? Do you know what it looks like? Those little bumps that are on the twigs of the sugar maples.
I put up a link to a PDF out of University of Vermont, so people can take a look at it if they haven't seen it. It's very. I mean, all this stuff is interesting when you just think about the abiotic and the biotic predisposing and inciting conditions that lead to outbreaks of animals that are kind of just there as background noise, and then they blow up into problems.
Yeah, that's really one of the that's what we get together and talk about at forest entomology meetings. Is so what is it that pushes these bugs to the point that they become outbreak? And unfortunately, I think in the world of bug funding, those projects that are looking at what are those triggering mechanisms just don't get enough attention. The bugs that get attention are the ones that are causing all the problems, and when they go away, they think, oh, no more problem, let's stop throwing money at it. So we never really get to that point where we can say, yes, definitively, this is what happened to cause that outbreak.
So the other thing that I did, you were talking about armillaria. So I just started, towards the tail end of your presentation, I started a blog post on the Ning site. And I'll add to that. So it's called Entomology of Sugar Maple Forests. And I included with that a picture of armillaria. So you were talking about armillaria. And I put that, the ForestConnect.ning.com URL up. So if people want to see, if they haven't seen armillaria, they can see it. And then when, after we finish recording this presentation, I'll post the link to the recording there as well, and some other things. And that's a good place if people have questions and they want to talk more about this, they certainly can. And this is, if you all have questions, this is a good time to ask them. So Paul Hetzler, we know Paul, our friend up in St. Lawrence County.
Yeah, thanks, Paul.
Says that he sees that Leucanum scale killing understory maples and corylus, the hazelnuts. in '06 and '07. Interesting.
Yeah.
So is there, Mark, the leucanum I'm taking from this, leucanum attacks more than sugar maple?
Yeah, it's a broad-based insect. I think that we just notice it on maples because we're concerned about it. And so that's one of the questions, it's like, how does it interact with the different trees around, and how do they then influence the population outbreak on trees that we pay attention to? Coryllis is a good example. I mean, that's just an understory tree that really doesn't really have much economic importance, but it's something that it, then again could contribute to the population growth in other more economic species. So I like the question. Well, I didn't realize sugar maple is all the way up there close to Thunder Bay. That's where I like to go canoeing. The most northerly population. What's the prognosis for the future? I think it sounds great. Actually, I love to ski, so I'm thinking of migrating north, so I still have snow. Yeah, I would say that you're in good place up there, and indeed, you might actually think about planting more sugar maples. I know that I was actually giving a talk in Aurelia, Ontario, a couple of years ago, and one of the points of discussion was what should we be planting in our forests? Should we be shifting our emphasis away from maple in southern Ontario to more towards planting oaks and hickories? And I think that's a really good question. I don't really, I would consider that, because we're moving, the things are going to be shifting so rapidly, just in a few decades, that these herds of oaks and these herds of hickories don't move as rapidly as do the maples, which have the seeds that fly so well through the air. And so are they gonna be playing a game of catch up? I don't know. It's good stuff to think about, and I would consider planting more oaks in the forest right now that are heavy to maple.
So, Mark, there's a question that came in to me as the host, and it's addressing spray programs for it says Eastern Tent Caterpillar versus I don't know if that's relative to Forest Tent Caterpillar. Maybe if you have, if there are differences between Eastern Tent and Forest Tent, maybe comment on those. I know about 10 years ago we had an outbreak of Forest Tent Caterpillar in the sugar bush at the Arnott Forest, and the following year, so that was a defoliation that happened as the leaves came out. The year following that first, so we had 1 year we had just a little bit of Forest Tent Caterpillar. The next year it was full blown. We lost the canopy on probably 80 or 90% of the sugar bush. The following year, our sugar concentration dropped from what's normally about 1.8 to 2.0% sugar, which is decent, down to less than 1% sugar. So it was, the magnitude of that was, instead of boiling 40 gallons of sap to obtain 1 gallon of syrup, we were more like it 80 to 100 gallons of sap per gallon of syrup. So anyway, wow. Talk a little bit about spray programs. Yeah. What are the options for Forest Tent and Eastern Tent Caterpillar?
Yeah, I forgot all about that. I apologize, because it's a really important thing. It's just one question for you, Pete. So did you not tap some of those trees and then see how well they recovered, or did you maintain your taps in all the trees out there?
We continued tapping as normal. So that would have been, so the first year, let's say, just to pick a number, we had a 10% to 20% defoliation. So no tree was completely defoliated. There are several trees that were chewed on. The second year we had very high levels of defoliation. I think the only trees that weren't defoliated were red maple, and then in the edges in our sugar bushes, largely monoculture, which is not a good thing. But in the areas where we had mixtures of species, the sugar maples that were there tended to have slightly less defoliation. In the areas where it was pure sugar maple, the forest tent caterpillar fully defoliated. I mean, like it looked like December. I mean, you've seen it, but it looked like for the people listening, it looked like there was no foliage, and it was an eerie sort of. Following spring, we sprayed with Bt, Bacillus thuringiensis, and that broke up the population, and we haven't had any problems since.
Yeah.
We changed the tapping pattern was the same, and I'm not aware that we had any health issue with the trees where there was both defoliation and consistent tapping pattern.
Yeah, well, that's really interesting. You know, my recommendation, of course, is to let those trees have a little bit of rest, so
which we might have if we had more than one. If we had more than 1 year of defoliation, we may have done that. But
yeah, right. So yeah, basically, Bacillus thuringiensis works really well on forest tent caterpillar, and I know that Cotton Hanlon was treating a lot of their lands with Bt as well. Actually, I had an interesting experience with it though, because I have a friend that has land I mentioned earlier on top of a hill out there in Richford, and he actually had his land sprayed as well with Bt, but he got his populations coming back for 5 years. It was the only place that I actually saw forest tent caterpillar persist all the way until 2010, and he lost a lot of trees. It was very significant. So in that instance, the Bt was ineffective, and he wasn't going to spray again. He just did because Cotton Hanlon had land nearby, and they said, "Hey, you want to go in on this?" And he said, "Yeah, that sounds great." So you know, it worked on Cotton Hanlon's land, but not on his, and I think that's because his soils were just that right, amount of dryness that the trees were stressed. So, and the same thing, I'm not really, that familiar with the eastern tent caterpillar and the efficacy of Bt on those. I imagine it's very similar because it's the same toxin, and it's it's a congener of the forest tent caterpillar. And I know that there's been some large outbreaks of eastern tent caterpillar down in the black cherry areas there of the northern Pennsylvania, northwestern Pennsylvania, really very large outbreaks that they did treat. So that's what I know about treating them.
So what I've heard is that the Bt is a bacterium, and essentially there's a narrow window. So correct me when I get off. Yeah. So it's like a crystal that has to be made available to the larvae when they're in an early instar stage. So the timing is very important. The crystals essentially scour the gut of any caterpillar, so it's not specific to the forest tent or eastern tent caterpillar, but any caterpillars that are out there would be impacted by that. So that it's not without some consequence, but you're weighing the consequence of potentially significant tree mortality and other factors. Yeah,
the thing about Bt is that you're right. It's a generalist. How do you say? It's a toxin that affects only caterpillars, and they have different strains that are effective on different insects. Now, the kind that's effective for mosquitoes as well. And the problem with it is you're right. You want to get it into the larvae just after they hatch, so that they don't cause much damage as they feed. And so you have to time it exactly correct, and try as exactly as possible. And one of the problems is that so you got to watch when the majority of the population's eggs have hatched and the young larvae are beginning to feed. But then one of the problems also is that the toxin actually can be photodegraded, and so radiation actually renders it ineffective after a short period of time. So you have to be sure that you're watching the window. You don't want to have a bright sunny day like we have in Ithaca right now. It will rapidly degrade the toxicity of the bacteria. So it's it's not the where all with end. It's not it's not the, how would you say, the absolutely most perfect thing in the world, but it's as far as a wide scale application of something in a forest. I think it's definitely the best way to go, as compared to the good old days of spruce budworm projects with DDT all over hundreds of thousands of acres.
Right. All right. Okay, so Jack, no, Peggy wants to know, is there a website to track insect outbreaks in northern hardwood forests? It's kind of a neat idea. I don't know if it, does that exist? So could somebody go and look, and, I mean, maybe it wouldn't be, be something that would be updated on some regular interval to look at peaks or cycles or patterns, or I'm assuming that's like an annual thing, like where is gypsy moth hot this year, where is forest tent hot this year?
Yeah, so basically the Forest Service is the place where all this data goes. They actually pay the individual states to survey their forest lands, and then they collect all that information and they then compile it. So I don't really know. I just ask for updates on the maps, and I get them, like for hemlock woolly adelgid and for balsam woolly adelgid and other things. So that's interesting. It'd be something that would be very easy to do, it seems, but then not by me, because I'm not a computer whiz. But it seems logical, and I would go to the Forest Service website and see what the heck they find, and if you can't find it, shoot them off an email and ask them, if you can. In fact, I'm going to do that myself. That'd be fun to sit down and play around with that sometime.
Well, and if anybody, I'll see if I can find that as well. If anybody else finds it, send me an email or go to the Ning site that I posted just a minute ago and put in a comment that says this website with maps of insect outbreaks. So it'll be, that blog site can be a place to kind of a clearinghouse for information relative to this.
There's an interesting question. But EAB has killed most of our ash trees. They only eat a thin layer of the inner bark to kill the tree. Actually, they feed on the phloem. It's not just the inner bark, the cambium, but they really do take out a good chunk of the phloem. We've tried to kill Norway maple in a tree row by girdling it 1.5 to 2 inches deep by 6 inches wide, but that failed. It still leaked out last year.
Isn't that always the case?
It lived all summer. Dang, it's like how did it survive? I mean, that's a good question for you, Pete. I know that when we work with emerald ash borer to attract it in, we actually do girdle the ash trees, and I don't go in very deep into the wood, but I do take off like a 6-inch band of bark, and they die pretty quickly. And I know that when I was growing up out west, we have a tree out there called big leaf maple, and I did try to girdle some of those, and they did the same thing. They persisted for like 2 years before they finally ran out of steam and died. So, my advice is just wait it out. It'll die.
And Peter Collin responded. He says it takes sometimes a year or two for the trees to die. I'm not surprised that if you did this. It looks like in the spring of last year that it survived throughout the year. My guess is this year it may leaf out a little bit. The leaves will be diminished in size, and they may not survive. So that would be that's certainly a possibility. I did a flame weeding project with beech saplings, and I flamed them until the bark was glowing red, and I monitored those saplings for up to 4 years, and the beech trees continued to leaf out. The bark had fallen away. There was fungi growing out of the wood, but you would never know it from the leafy crown of the beech trees that I mean, they were dead and they didn't know it. They ended up falling over because there was an October snow load that hit the leaves, and the wood was brittle enough that they just broke. So the thing with girdling is if you have a small stem, it's fairly easy to succeed. If you have included bark, if there's any vascular tissue that you miss, it doesn't take very much, a half an inch or an inch, and that tree will stay alive. So that's what Peter just commented on that as well.
Yeah, they're just fooling with you, Pete. those
Yeah,
trees. They know you.
So, all right. Well, Mark, I think we've captured the questions. I want to thank you. This was a great presentation. You hit on a whole bunch of insects that are possible encounters for people walking in northern hardwoods forests and maple woods, and I want to thank you. I want to thank the participants. So hope you all have a great day.
Yeah, thanks everybody. I appreciate you being there and listening.
Thank you.